Hello everyone. Now we go talking about simulation of short circuit in neutral system TN. In system neutral we have TT, IT, TN. TN we have 2 TNC, TNS. Combination between 2 we have TNCSC. For diagram of neutral system TN we have earthen and notated with BA. BA notated with N. That's mean BA and neutral is same. We have not neutral. We have BAN. This diagram we have 3 phases, phases 1, phases 2, phases 3, and Berger 3-pole Berger, and we have messes. So when we have false, example, we have false in phases number 1, so it's created false current follow these loops, follow to PA cables or wires and go to N and go to A to phases and return and rotate with 2 messes or car keys. So it's drawing these loops C, D, N, A, B. How go to do calculate? In this lesson we go talking about circuit breaker characterization. We go talking about caliber, which caliber is based of informations calculated by supply power estimated, and we have go talking about insulation false when basis for short circuit. We go talking or concretization, or we go concreted maximum disconnection times when we can determine tripping times TC, and we go talking about we go concreted breaking capacity. So this diagram is translated by equivalent circuit. Thus we can represent impedance of phases of cable phases when we have false, and we go represents impedance false when we have false contact, and we have messes. We go represent impedance of PA cable earth. We have messes, and we have neutral, and we go represent impedance neutral and impedance and the earth. So we should calculate fault current which passed in this circuit, passed by cable phases by impedance phases and impedance default and impedance LCD. Okay, so we have formula impedance and current fault currents equal voltage by voltage per impedance equivalent this circuit. Which voltage is voltage network? When we have current fault, we have characterized short circuit. We say about short circuit. When we have short circuit, so we have drop voltage of 20%. For impedance, we can calculate impedance of 1020 millimeter square. In these cases, reactance is nil, is equal to 0, and so impedance came equal resistance of cable 18 PA plus resistance of cable faces. For how we can calculate this resistance? We calculate this resistance of this formula. Resistance equal rho times length the cable per section air. So we for rho equal 22.5 times 10 exponent minus 3 millimeter square per meter, of which we have of cables cable cables. When we have aluminum cables, aluminum natural cable, that means natural cable is aluminum. Rho came equal 36 times 10 minus 3 millimeter square per meter. So when we have about case section of cable greater than 120 millimeter square, in this situation reactance equal 0.06 times 10 exponent minus 3 ohm per meter. So for this example, we have section equal 35 millimeter square. It's less than 120 millimeter square. So the reactance is negligible, is equal 0. So we can calculate it or do calculate it with length equal 50 meter. So we have we concluded fault current equal 3576 ampere. It's very high. It's short circuit. So we can calculate it contact voltage. That's contact voltage between calculus and earth. Is equal resistance of cable earth AP times current fault by application, by a number of application we constate resistance of 18 equal 32.50 times 10 minus exponent minus 3 ohm. So voltage, contact voltage equal 115 voltage. It's dangerous in a safe this voltage it's greater than 50 volts. Okay, so we can determine maximum disconnection driven times standards, which we have voltage, contact voltage equal 150, it's between 50 and 120, and diagram we have Tn. So you should for driven times Tc you should less than 0.8. So we can concrete it Tc driven times by this curve based of ratio of current, fault current and normal current. If we have ratio less than 5, we can extract by discover B of zone B. If we have ratio between fault current and normal current is ratio between 5 and 10, we extract or we concrete driven times Tc based of C cover. When we have greater than 10, we base it to extract this driven times Tc of D cover. Okay, we go calculate maximum length authorizes of cable PA. Is short, it's limited, it's short less than this value, which calculates of this formula. L maximum equal 0.8 times section of faces times voltage of network per rho times 1 plus m, which m is ratio between faces AP and faces times normal current. Okay, so goodbye, that's enough. See you next time. Bye. Times normal current. Okay, so goodbye, that's enough. See you next time. Bye.